Allacademy. Always with you.
Hello my dear students, welcome to this online video session on basic thermodynamics. So in the previous session we have already started with the second law of thermodynamics, that is module 3, and we have also discussed the introduction to the second law of thermodynamics, and we have discussed some of the important terminologies that are used in while studying the second law of thermodynamics. Now in today's session we are going to discuss the definitions of a second law of thermodynamics. Unlike the other laws, this second law of thermodynamics is defined in two statements, so that we're going to discuss in today's session. Then also we'll discuss the equivalence of a Kelvin Clausius statement. That is a very important topic. So repeatedly these questions are framed on this particular topic, that is equivalence of Kelvin Clausius statements. And then last in the today's session we're going to study the perpetual motion machine, second kind. So already we have discussed what is a perpetual motion, first kind, in the first law while discussing the first law of thermodynamics. Now in today's session we are going to discuss the perpetual motion machine, that is of second kind. So without wasting much time, let us start with today's session. So as I already said, so this second law of thermodynamics is well explained or well defined by the two different classical statements. That is, one is Kelvin Planck's statement and another one is a Clausius statement. So these are the two different statements which helps us to describe the second law of thermodynamics in a different ways. Now if the question is asked, so you may have a question that, sir, which definition we have to write if the question is asked on the second law of thermodynamics. If the examiner asks you to define or explain the second law of thermodynamics, then you have to write both these definitions, both the definitions, that is Kelvin Planck statement as well as Clausius statement definitions has to be written and it is explained. Now let us study the one by one in details these statements. So let us go with the first statement, that is Kelvin Planck's statement. So that is the first one is a Kelvin Planck's statement. So what is this statement says? It is impossible to construct. It is impossible to construct a device working in a cycle whose sole effect is to convert all the heat energy supplied to it into equivalent amount of work. So this is a definition of work. So it says that means whatever it is impossible to construct the heat device. This is assume that this is a heat engine. It is impossible to construct a device which is working in a cycle whose sole effect is to transfer or convert all the quantity of heat energy which is received from the heat source into equal amount of work. So it is not possible. That is a simple definition of work. It says that we cannot construct a device which can be 100% efficient or which can convert all the heat energy into all the useful work. So that is a simplest definition of a Kelvin Planck statement. So once again I will repeat. So what is this Kelvin Planck statement? It is impossible to construct a device which is working in a cycle whose sole effect is to transfer or transmit all the heat energy supplied into useful amount of work. So this is a simple definition of Kelvin Planck's statement. Now let us discuss the another one definition, that is Clausius statement. So what does it say? So let us discuss that one. Now this Clausius definition, it is just a reverse of what we have studied the Kelvin Planck statement. So it says that it is impossible to construct. It is impossible to construct a device working in a cycle whose sole effect is to transfer energy from, that is heat, from energy in the form of heat from lower temperature body to higher temperature body. Please note, very important, we all know that the heat always transfer from higher temperature to lower temperature, but the Clausius definition says that is only, it relates to that itself. It is impossible to construct a device working in a cycle whose sole effect is to transfer the energy in the form of heat from lower temperature body. Means it is impossible to from here, from this I cannot transmit. It is impossible to construct a device which is working in a cycle which can transmit the temperature from lower temperature reservoir to higher temperature device. So that is a simplest form of an Clausius statement. Once again I will repeat, it is impossible to construct a device working in a cycle whose sole effect is to transfer the energy in the form of heat from lower temperature body to higher temperature body. So this is a simple form of a definition. As I said, no, so if the question is asked, write or define or explain the second law of thermodynamics, you have to write both the definition, that is Kelvin-Planck statement as well as Clausius statement, along with these diagrams whatever I have shown here. Now please note that so while discussing that, you may have a questions that, so both the statements is something, it gives a negative, in the negative form they are giving. Yes, so both these Kelvin-Planck statement as well as Clausius statements, both the statements are negative statements, and it is extremely difficult to prove the negative statement, unlike other physical laws. Physical laws, as the second law, it is purely based on the experimental. Already we have discussed in the earlier stages in the initial, that is the first class, introduction class in this module. So it is the second law, it is purely on the experimental basis, unlike to the another, the mathematical model or the physical models. So it is purely on the experimental model. So it is difficult to prove the negative statements. It is difficult to prove the negative statements. So sometime they make the question may be asked, the second law statements are positive statements, negative statements, none of the above. You can write, you have to choose the answer, that is the second law definitions are negative statements. Now let us move to the next very important topic in today's session, that is equivalence of Kelvin and Clausius statement. Now what is this equivalence? So many students will not able to understand what is this equivalence, because in every year the questions are framed on this topic. So 8 to 10 marks questions are framed on this topic, and many students come without attending these questions. So they just solve the numericals and they will leave this. So it is very simple to understand what is this equivalence of Kelvin and Clausius statement. Now, the two statements of second law may not appear to have anything to do with the one another. Means they are not connected, because in one statement it is said that it is not possible to construct a device which can transmit heat into one. But whereas another definition it says that it is impossible to construct. But what it says, to transfer the temperature from lower body to higher body. One, it is saying that conversion of work. Another statement it is saying that it is impossible to construct the device which can transmit the energy from lower temperature to higher temperature. So both are not related, but in fact each other implies other. Means the Clausius and Kelvin-Planck statement of the second law are entirely equivalent. Now this equivalence can be demonstrated. Means how I can say that both are equivalence, both the equivalence of Kelvin and Planck statements, I can equivalence that by demonstrating by showing that the violation of either statements can result in the violation of any one. Means if any one statement violates its law, so then obviously it also violates the another one. So by doing this, by demonstrating this way, so we can say that both are equivalent. Means both the statements can give a equivalence. Now let us discuss in details about how this violation of the laws will take place. Now let us start with the first one, that is violation of Kelvin-Planck statement results in the violation of Clausius statement. Means, so we know that the Clausius statement is different, Kelvin-Planck statement is different. If the Kelvin-Planck statement violates, then it results in the violation of which one? Clausius statement. So that please note that these the sentences make you a bit confusion while studying this one. So please be careful. So here the first if the Kelvin-Planck statement violates, then it results in the violation of a Clausius statement. Now what is that one? So consider the heat engine that operating in a cycle. Now this is a heat engine I am showing here. which is operating in a cycle. Then it takes the heat from the heat reservoir, that is a QH, which is at a higher temperature. We know that heat reservoir, it is always at a higher temperature, and it takes the heat from a heat reservoir. And it converts all the heat energy taken into a complete useful work. As I have shown, that whatever work is done, it is equal to QH, that is amount of heat absorbed from the heat source. Now complete work, so which violates the first law of, that is which violates the Kelvin-Planck statement. So what is Kelvin? No, while understanding this one, you must remember, you have to correlate with the definitions. So actually what Kelvin-Planck statement says, that it is impossible to construct an engine which is or a device which is working in a cycle whose sole effect is to transfer all the heat energy into work. It is impossible. He said that impossible. So in this one, what is showing, whatever heat energy is there, it is completely converting into work. So it violates the second law of thermodynamics, that is a Kelvin-Planck statements. Now let W, which is equal to the QH. Now here, whatever as based on this experiment, it shows that whatever amount of heat is there, that is equals to amount of work. Now be utilized to drive the heat pump, means we know that to transmit the heat from lower temperature reservoir to higher temperature reservoir, I need to do some work on the system, that is pump I need to use, which can transmit from a heat from lower reservoir to higher reservoir. Now this work is utilized to drive the heat pump as shown in this figure. Now heat pump, here you can see the direction, which is in the upward direction, means lower temperature heat is taken to higher temperature heat reservoir. Now let the heat pump take the QL amount, that is lower temperature, low heat from the low temperature reservoir, and pump it to the high temperature reservoir, and the amount of heat to the high temperature reservoir. Here I can say that because QH is a work done, that is a QH, then L is a heat taken, so that is supplied to the heat reservoir. Now this, from the diagram we can say that, the QH from the part of heat, that is whatever heat is that, it is nothing but equal to work pumped to the higher temperature reservoir is delivered to the heat engine, while there remains the heat flow of QL from lower temperature reservoir to higher temperature reservoir, which in fact violates the Clausius statement. So here you can see this one. So QH is again, it is taken from heat engine and it is converted into work, means whatever work energy is there, that is equal to heat energy. Now this again, heat is supplied back to reservoir, but there is a remaining of an QL in this reservoir. So that violates the Clausius statement. So what actually Clausius statement says, that means there must, if it is impossible to construct the heat engine which is working in a cycle whose sole effect is to transmit the energy in the form of heat from lower temperature reservoir to higher temperature, it is impossible. So it is saying that it is impossible, but here in this demonstration it is possible. So it is possible, so it violates the second law of thermodynamics, that is a Clausius statement. Now this shows that the violation of Kelvin statement results in the violation of Clausius statement. Now let us move to the next one, that is a reverse of this. That is, if the Clausius statement violates, if the violation of Clausius statement which results in the violation of an Kelvin-Planck statement. So in a previous case, what we have discussed, if the violation of Kelvin-Planck statement violates the Clausius statement. In this condition, so here the violation of Clausius statement results in the violation of an Kelvin-Planck statement. Now consider the heat pump. Here I am showing that. Consider the heat pump which is operating in a cycle that takes the amount of heat, that is QL, from the lower temperature reservoir to higher temperature reservoir. So this, that is low temperature reservoir, transfer the heat equal amount of QL to heat, that is HTR, means higher temperature reservoir, which violates the Clausius statement. As it is, we know that it is impossible to construct. Please, again I am telling the definition of the Clausius statement because there it connects. It is impossible to construct a device working in a cycle whose sole effect is to, impossible means it is not possible, but here QL is supplied, so it violates the Clausius statement. Now let the amount of heat, that is QH, which is greater than QL, that is QL means low temperature heat, be transferred from a high temperature reservoir to heat engine. Means here it is supplied to heat engine. An amount of heat, okay, an amount of heat, that is QL, be rejected by to the LTR, that is low temperature reservoir, and the amount of work W, which is equal to, that is QH minus QL, that okay, the amount of work done in this condition will be equals to amount of heat transferred from lower temperature reservoir, higher temperature reservoir, minus amount of heat transferred from the lower temperature reservoir, be done by heat engine by the on the surrounding. Since there is no change in the heat transfer in the lower temperature reservoir, LTR means low temperature reservoir. Now the heat pump, the heat, that is HTR, that is higher temperature reservoir, and the heat engine together can be considered as a device. Means here completely it is considered as one device, and which absorbs the amount of heat, that is QH minus QL, from the high temperature reservoir, and produces an equal amount of work, that is W is equals to QH minus QL, which in fact violates the Kelvin-Planck statement. So here means, as Kelvin-Planck statement, what it says, it cannot convert all the heat energy into work, but here what it is showing, it is producing an equal amount of work, that is QH minus QL. So that violates the Clausius statement. So in the examination, definitely these questions are framed. Okay, so you have to explain how, if the question is asked, show that equivalence of Kelvin-Planck statement, so then you have to explain both these conditions, that is violation of Kelvin-Planck statement violates the Clausius statement, and also you have to explain the violation of Clausius statement results in the violation of Kelvin-Planck statement. And in some time in the examination, directly they have asked, show that the violation of Clausius statement results in the violation of Kelvin-Planck statement. In that condition, we have to explain only that whatever the question is asked. So no need to explain other type. And in some question, they have asked the violation of Kelvin-Planck statement results in the violation of Clausius statement. In that condition, explain the previous one, what we have discussed. Hope you have cleared this one. Just once again you go through the video so that you can easily understand, because I have given the diagram, colorful diagram also, so that you can easily remember this one, and you have to draw this, the diagram you have to draw while explaining these two conditions. Now let us move to the next topic, that is perpetual motion machine second kind, that is PPMK-II, perpetual motion second kind. Now what is this perpetual motion? So already we have discussed perpetual motion first kind while discussing the first law of thermodynamics. Now without violating the first law, that is the first law of a machine, can be imagined which would continuously absorb the heat from a single reservoir, would convert this into complete heat, that is whatever from one reservoir, if what it says that the perpetual motion second kind, it can be, the machine can be imagined, it cannot be possible, but it is an imaginary machine that continuously absorbs the heat from a single reservoir and converts all the heat energy taken from a single reservoir into useful work, which means that the efficiency of such machine will becomes 100%. Such machines are called perpetual motion second kind, perpetual motion second kind. Now a machine of this kind would violate the second law of thermodynamics, hence it does not exist. As I said, no, these are the imaginary machine which absorbs all the heat from a single reservoir and converts all the heat into useful work. Then the efficiency becomes 100%. So such machines are not possible, and in that condition we say that such machines, if they exist, such machines are called perpetual motion machine second kind. Now for this one, I will take a small demonstration so that you can easily understand what is exactly this perpetual motion. So, and while explaining this one, you have to explain, draw this both the diagrams so that you can easily explain it. Okay. Now let us assume the heat source. Okay, heat source, which and this is an heat engine. Okay, this is a heat engine which takes the amount of heat from the heat reservoir, and it do all the work, and it means it converts all the heat energy into useful work. So then the W will be equals to amount of heat transferred, means amount of heat energy supplied. So here the efficiency becomes 100%. Now here that can be explained in the by taking this simple experiment. Okay, now assume that this is a piston cylinder arrangement. Okay, I supply some amount of heat and it will start to operate. Means if I supply 10 kilojoules of an heat to this piston, and it produces the same 10 kilojoules of work by rotating this wheel. So then here whatever amount of heat energy is supplied, that will be equals to amount of work done. So then efficiency becomes 100%. Now such machines are called as which violates the second law of thermodynamics. Such machines are called perpetual motion machine second kind. And what are the perpetual motion machine first kind? Which violates the first law of thermodynamics are called as a perpetual motion first kind. What is a perpetual motion second kind? That is which violates the second law of thermodynamics. And even these questions, this question is asked in the examination for 6 to 8 marks. Sometimes it is asked for 6 marks and sometimes it is asked for 8 marks. So based on the quantity of marks, you have to explain it, because you have to explain this one, how this draw the diagram and explain it, how it is proven, how it is violates the second law of thermodynamics. That you have to explain it. But what is the actual means? How in simplest way I can say that it is a imagine that which absorbs, it is an imaginary machine which absorbs the continuous amount of heat from a single thermal reservoir or from a single reservoir and converts all the energy into some useful work. So which violates the second law of thermodynamics. Okay. So okay, my dear students, so the whatever the topic we have discussed, so in details we have discussed about the two definition of a second law of thermodynamics. And very important, very important, that is equivalence of Kelvin and Clausius statement. That is very important, and both the conditions we have discussed along with the figure. Then perpetual motion we have studied along with the experiment, and along with the definition also we have studied. Still, if you are finding any difficulty in understanding these things, you can comment it in a comment box and I will try to clarify your doubts. And dear students, you can also download the notes of all the modules from our website, that is Allacademy for you blogspot.com. And also you can follow us on a Facebook as well as Instagram, and in a Telegram channels where the PDFs will be shared. So till that, you just share the video to your friends and watch the video if you're not able to understand any concepts, and share the video to your friends also.
Click on subscribe button and press the bell icon to get updates from Allacademy.